film school background, and I kind of dug my way up into video engineering. I kind of started in film school, went to Discovery Channel, and now I'm here at Comcast. I'm a software engineer for the video on demand ingesting side. It's really exciting. And hopefully we could really start this community, get a good relationship, and go from there. Glad everyone's here. Today we have some amazing speakers. We have Steve Robinson. He's from YouTube. And we have Matt McClure. I'll do the introductions a little bit later. And from Demuxed and San Francisco Video Meetup. But for now, I just want to introduce myself and go from there. So, and then this is Dave Leach.
And I'm Dave Leach.
That's Dave Leach. Dave Leach, everyone!
First of all, thank you for the Comcast Vader organization for letting us use their space. So thank you, Colleen and others. Really appreciate that. And thanks, Matt, for getting us some pizza. So appreciate that. And you coming out. So I've been in, I work with Doug. I've been in the, been working with Comcast about 20 years, but only in the video part of the organization for a couple of years. So ever since I got here a couple of years ago, got to know Doug, and we've been talking for, I'd say, all of those 2 years about putting together a meetup just like this. So thank you again, Matt, for helping us get it off the ground. Really appreciate that. And Steve, who we'll meet here in a few minutes. Thanks for coming. And last but not least, James from Wowza is part of the creation of this group. So would love to have you introduce yourself.
Yeah, it sounds so formal when you say creation. I mean, literally, it was at Demuxed this past time. We literally hatched it out. Ready to order.
It was at an airport.
So yeah, I mean, I guess.
So yeah, you helped in those 5 minutes. We put it together, right?
Yeah, it was great. So, but yeah, I work with Wowza Media Systems. So we're here in town. If anybody doesn't know us, since we do a lot of video streaming. Me personally, I've kind of had my head up my rear for the past 12 years or so, building SaaS platforms of different varieties. So one with Timber Networks, doing a lot of smart grid things. Also doing a lot of developer enablement. So at Wowza, really what I do is a lot of developer enablement, a lot of solutions and tech marketing sort of things, and working to do things like this and sponsor hackathons and get together with folks and try and figure out what we're doing. And as Dave, the CEO, says, he says, I'm the director, who cares and why? So that's really what I do. But I want to thank everybody for coming out, really appreciate it, and we'll be talking a little bit more, so thanks.
And I just want to give one more shout out, I think, to the sponsors. This facility is, and the drinks are taken care of by Comcast. Of course, we have Matt McClure from Wowza who came with the pizza, and they flew down here. What did I say? What did I say?
Wowza. Surrounded by Wowza people.
I meant
Just sitting next to Wowza.
But we respect Wowza, and I'll get to that after. And Wowza, of course, is doing a live stream right now with their, I want to say live cast, but it's the Clearcaster to Facebook right now as we speak, and that's huge. So hopefully we have a lot of viewers on that. And they came and set that up. So I just want to thank everyone who really sponsored this, and hopefully we can continue on as we go. But without further ado, let me introduce Matt McClure. Matt, of course, started the San Francisco Video Technology Group in 2003, and the Demuxed Conference, which is definitely the really most amazing video engineering conference out there. And a big contributor to Video JS and a co-founder of Mux. So go ahead and take it away. Cool.
The joys of a USB-C laptop is getting to carry a dongle around all the time with you.
Oh gosh, the dongles.
Should maybe just push this.
Wow, technology works.
Except for the part where I've frozen up here.
Nothing wrong with that.
Did we freeze you?
Did we? You might want to unplug and replug.
I
Is
think
it
I
blinking? Is it blinking green?
No. I'm getting the...
No Wi-Fi?
No, I've got a beach ball.
Beach ball of death.
Oh,
Oh, that's great.
don't you love it? Doug, you need this dongle. This is a better dongle.
That's a way better dongle than mine.
That would have been smart, but no.
No?
It's okay. I think we're good.
Is it better now? Press the button. So what? I want to push the button right when he's ready because I wonder if that's going to make the beach ball happen.
Oh, there we go.
Okay, I'm pushing the button. The button has been pushed.
Cool.
Okay.
Cool. So thanks again, everybody, for coming. I had little to nothing to do with this except for being in some balls. So another round of applause for these guys for putting this together. So as they said, this is just kind of an overview of like Demuxed and SF Video and kind of how we see community at Demuxed. Started SF Video back in 2013, and it was one of those things where we got lucky with kind of a core group of folks that kind of kept coming out every month. And Steve and Matt Ward are two of those people that, starting in 2013, this is Steve. You can tell that his hair looks a little bit different now. Back then he had beautiful flowing locks, and since he's got them off. But yeah, we got really lucky with like a great core group of folks that when we needed speakers would come out. When we just had any event, they would still just come hang out and support the speakers. And you know, the first SF Video in 2013, I think it was September, we probably had like 14 people, so already this group is winning on that front. But yeah, I mean, like it turned into, we haven't missed a meetup except for November and December. We made the unfortunate decision of going with the last Thursday of every month. So November and December are a little bit of washes when it comes to attendance. So we decided not to even try. So aside from those 2 months, which we purposely don't have meetups, we haven't missed one, and that's largely thanks to being able to call on the group and the folks like Steve and Matt and one of the other 6 Matts that are in the group, like myself. Put up the Matt signal and somebody will come speak that month if we really need it. So yeah, out of that, so 2 years in, we started Demuxed. People have been asking, like, you know, we love coming to this meetup every month. It's just this kind of format, like coming in, relatively informal talks, chatting. Like one thing that I love about our group is that folks feel free to kind of ask questions at any point during. It's much more of a conversation than like keynote talks, for example. So at any point in the conversation, people in our group feel fine, just like raising their hand and asking or shouting out a question and interacting with the speakers, which has been really great. But people started asking, like, you know, this once a month, this is great. It'd be really great if we could digest this into a day or two, so my friends from out of town could come and also enjoy the same kind of content because they weren't seeing this elsewhere. So we started the first one with my lovely design skills. We created one of the uglier logos I think I've ever seen. So that was in 2015. Fast forward to 2017, last year, we started off with about 120, 130 people at the first one. Last year we were way oversold at 300 with a big waiting list. So yeah, I mean, it's resonated. People have really enjoyed you know, technical video content and being able to talk about it with their peers. So what we see is so also, by the way, we have dates set for this year. So shameless plug, October 17th and 18th, if you're interested in coming. If you went last year, our chairs are going to be more comfortable this year, I promise. That was like the most common piece of feedback I got was, love the talk, so it was great, get better chairs. So yeah, so ultimately for Demuxed, if you had to ask what my goal is for Demuxed to begin with, and kind of what I see us as contributing is community. So I really want people to see Demuxed, come to these meetups, come to start their own meetups, come to the conference, write content, and then like see anything related in any way affiliated with Demuxed, and feel like it's making it easier for them to be a part of our industry. I think the video industry at large is pretty insular and pretty hard to get into. We're solving hard technical problems, as you all know. So it can be daunting and like difficult to onboard yourself into that. And especially with our very special level of jargon, it can be hard and intimidating for new people to be a part of it. So our goal is to kind of facilitate this through things like this. This is, like this meetup itself, I think continuously SF video is the most important thing that I do in terms of video community in San Francisco. And it's grown, like now, so just this month, we have this one, at the same time there's one going to LA, there's one in Paris, Sydney, New York, London, San Francisco, Berlin. The Berlin is another one that just started, and this is all just in the next 2.5, 3 weeks, which is really, really cool. So, yeah. Again, except for the San Francisco one, I have little to nothing to do with these things on an individual basis, but
I think you have to do with it, you think?
well, I think who really make these things happen are everybody that's in this room. You know, next time they need a speaker, one of you people here should speak and present and contribute back, because without that, the organizers are hung out to dry. You will have a few months where you will end up writing a talk at the last second because you have nothing else to do. Nothing else to do, nothing else that you can do to make it happen. So other things that we try to do to support the community, all of the Demuxed events. This is another thing that like we put everything up online. Also all the SF video talks, recording and putting these things online. I would like to be better about centralized locations, but just getting more information about this stuff online and resources. Every little bit helps. We do a podcast. If anybody is interested in being a part of it, shoot me an email, matt@demuxed.com. We're not very good about like actually organizing them in terms of time. So whenever somebody comes to us and says we want to do one, then that's when we record one. So shoot me an email if you're interested. But something that we can all do that I have really been trying to make a priority this year is producing content that's kind of evergreen. So this is one that just kind of popped up on my radar recently. This person started doing a like libav FFmpeg the hard way. And it actually starts off with a really excellent primer on how encoding works and what the basics are. And then dives into how to actually use FFmpeg, which is fantastic. So things like this are great. Find them, contribute to them, write your own. If you tell me about any of these things that you guys create, I'm more than happy to do whatever Demuxed can to put that in front of other people. And it doesn't have to be useful in any way, shape, form, or fashion. I don't even know what the device is, but this guy's speaking at the video meetup this month, and it's about like making a flower bloom by controlling video controls with your mind. Which seems very useless, about as useful as an Oculus, but it should be pretty cool. And then video dev is another one. So this isn't like a Demuxed thing, but it's a really great community in Slack. We're on this. We did a lot of the planning for this meetup on there, and it's just another place where it's really helpful for people to be able to have a place and ask questions. Stack Overflow is hit or miss. Lots of places on the internet are not very helpful for people that have no idea what they're doing. And for the most part, this community has been really great about bringing people up and helping people with their problems. If they don't know what an M3U8 is, that's kind of fine. And this community is great. So yeah, I was going to put up the like teamwork because all of us are dumber than one of us. But this felt a little bit more apropos. We're doing weird things with technology. So let's help each other do that. Yeah, deep thoughts. So yeah, if you're interested in helping out with any of those things, writing content, being on the podcast, speaking, whatever, anything that I can do to help, anything that Demuxed can do to publicize, to get your stuff out there, like ping me. We'd love to help, but again, I think the most important thing that we're doing here tonight is creating a community and helping folks be better at what we do, which in turn will make the internet better at delivering video, which is I think that's good for the internet. So anyway, thanks everyone. This is really exciting, and I'm so glad to be here. But without further ado, Steve, are you ready? Cool. Thanks.
Thanks, Matt.
I love my adapter equally. Dongle time.
So here,
There's an
See,
awesome.
Matt, is the best way to
there's a
get in
special
touch
bus.
with you, or is it a good way on that Slack channel that you mentioned?
Yeah, cool.
So then you might.
So I'm MCC on the video desk Slack, or just Matt at Demuxed.com. Any of those work. Or if you'd like, tweet at Demuxed, or I'm pretty sure send an email to anything at Demuxed.com. It will eventually filter it back.
So Doug or I will put some information on the meetup regarding how to join the channel and details about that.
Great.
We're not doing a resolve walkthrough this time.
Might work.
All right, yeah, so hi, I'm Steve. I'm at YouTube on the player infrastructure team, and I've done some stuff. One of the things that I've been working on a lot is HDR. And I keep getting the opportunity to give a talk with the same title with entirely new content. There's a totally new slide deck, and yet the title's been around for a while because there's always a new way. So in this one, let's talk about HDR. First, like, has anyone not seen HDR in person at this point? Like on a consumer electronics standpoint? Okay. All right, so we got a couple, but most of the crowd's actually seen it. So HDR looks really great, causes a lot of problems. Nobody really knows what to do with it yet. Part of the problem with running this as a delivery service for particularly a UGC content site is the metadata. One of the most important pieces of metadata is basic color imagery. This tells you when you have a file, it is encoded in you have a lossy compression codec for delivery, but you have a underlying format of like YUV420. And that tells you something, but it doesn't actually tell you how to map that into light. What you need is information about what color space it's in, which is actually something more than just one thing. It's what color primaries you have, and what transfer function you have. And what color matrix you have. And then in addition, you need to know the gamma curve that's being used. And we'll walk through all three of these in reverse as they apply to HDR. This thing, gamma curve, transfer characteristics or transfer function, depending on which standard you're looking at. You'll see a lot of people talking about forum posts on Hacker News and that kind of thing, talking about how the importance of the distinction between sRGB and a traditional gamma curve. That if you assume that content is gamma, but it's actually sRGB, you're going to scale it wrong. OpenGL is particularly known for people like making sRGB textures and stuff like that. So those are little fussy things that purists care about. This is not that. This is like straight up, everything will be terrible. So here's an image. Here's an image misinterpreted with the wrong HDR transfer function. Here's an image misinterpreted without an HDR transfer function that is HDR. So these images are just like wildly wrong compared to what it is intended to be. So that's the basics of HDR. Is in order to be HDR, it needs to be recognized as having one of these transfer functions. The two main ones being PQ, also known as SMPTE ST2084, which is the same transfer function that all of the Dolby stuff uses, but it doesn't imply Dolby Vision. That's different. And then the main competitor to that is HLG hybrid log gamma. And so you'll signal both of these. And one of the interesting things about PQ is that it's an absolute mapping. So it actually tells you if you have a particular code point, 750, it tells you display light at an absolute value of 1,000 nits. And a nit is well, we'll get to that next slide. But that's different from what you might think of for traditional gamma curves, which is typically environment or display dependent. So in this case, you'll see like, this is a log scale version of that chart, but it also shows you have two different ways to look at this. Perhaps a television in a dark room versus a television in a bright room, where you'll have the different TVs will be set to different brightness settings or auto brightness, particularly on phones or anything like that, will be compensating for ambient conditions. And PQ in theory is not like that. PQ says, here's an absolute value in nits, or candelas per meter squared. So that's saying like, if you have the light of, if you have a 1 meter panel and you fill it with 1 candle, that's 1 candela per meter squared. If you have that same panel and fill it with 1,000 candles, obviously that's going to put out a lot more light. So it's dependent on the size of the panel that is actually displaying the image in this unit, but it's a relative amount of light per area. So that's the condition. One thing that's interesting about this EOTF is that electro-optical transfer function, how you get from a coded value to the amount of light that you're putting out is. Just when you're like coding up demos and stuff like this or doing transfer functions, the formula is actually pretty complex. You know, gamma is just like one power expression. For PQ, you've got multiple power operations, and that turns out to actually be really slow to approximate, even on a GPU or anything like that, which has special function units. So when you're doing all kinds of video processing, you're going to need to like offload to a LUT or anything to get reasonable performance, because all of these operations are just dog slow if you have to do the power operation a million times. Another component that's part of the triad of basic color metadata is the primaries. And this is where we get to like wide color gamut. There are two main standards, the one used for HD. I'm glossing over all of SD and the nightmares that it causes. I'm sure being in the Comcast building that at least some of you are familiar with the SD, HD matrix and color space problems. But
you spend the next 20 minutes talking about
I would love to. I would. BT 2020 is the white color gamut, and you can see these on a chart here. The white color gamut is much wider. Hooray! The name actually makes sense. The pieces of metadata here will allow you to reach those much further primaries. The difference there is really obvious if you get that wrong, because the content will just look desaturated. But it is often confused with misinterpreting the gamma, because people will screw up. If they see a log images are flat, and flatness or a reduction in contrast also affects saturation, because it affects the distance between a dark color and a bright color, which is the thing that makes something saturated. So pure reds, pure greens, those will still actually work, but anything in between will look desaturated. So you can sort of just look at examples to tell the difference between those when you're trying to figure out if it's a color problem or a color primaries problem or a transfer function problem. Color space, which is where we're finally getting to actual practical problems, is what people are usually talking about. When people are usually talking about color space, what they mean is specifically color matrix. Because in an SD world, people didn't often do, sometimes they did, sometimes they were doing the right thing, but they weren't often doing primaries conversion. What actually happened that people screwed up a lot is they would use the wrong color matrix. And this is the way you get from YUV to RGB. A lot of devices in the wild, particularly consumer electronics devices that are, I guess it's worth noting, there's like the best places where video happens, and you'll see this at several points during the talk, the best environments for reliable delivery, for high quality experiences that work end to end are when like broadcast people or film people and like the software engineers and actual like broadcast hardware engineers are working together on stuff, and you'll see that in different standards. And when the software people do something, it's wrong. And when the broadcast people do something, it's impractical. And so it's the union of those two that really makes it happen. And so this is a case where this is like the software people just got it wrong. So in FFmpeg, you'll see color space used a lot. Color space only refers to color matrix, because that used to be the only thing that FFmpeg corrected for, because it was a math thing. You wouldn't actually, once you get to the primary stage and do like color correct output rendering, all the FFmpeg nerds were using Linux. Linux has no color correction. Well, I mean, it does now, sort of, if you're lucky, but it didn't for a long time, and like nobody had the correct displays, and so it was a mess. Software, the open source space just got colors wrong. And so if you're using FFmpeg, you'll see this misnomer. You have to specify color space, not color matrix, which has a big effect on SDR, because devices would infer the wrong color matrix or just straight up use one or the other in all circumstances, because nobody really paid attention to this, and plumbing the metadata all the way through never really happened. In HDR, this is still problematic, but at least because you have the other two variables, you have a decent chance at getting the color matrix also plumbed through correctly. And it's pretty important. You'll actually end up with a different result. Because the color matrix is based on the white point and then the hue angles that you need in order to get a luma channel from that white point. And they're not that far off between 709 and 2020, but they're far off enough that you'll get a visibly different result if you encode in 709 with a 709 matrix and decode with a 2020 matrix. And actually, a few of the early versions of the professional video production software were getting this wrong. They were producing content, labeling it as 2020, but internally using the 709 matrix. So we went around and asked them to fix it. And so that meant either writing properly that they were using 709, which they started doing for a minute until we found the next problem, or properly using 2020. And so it turns out that the problem with using 709 is that HDMI has no way to specify that. HDMI can say that you're using a PQ or HLG transfer function, and they can say that you're using a 709 or 2020 color system. But by color system, they mean color matrix and color primaries. And if you give something with the 2020 primaries, but 709 matrix, everything does something different. You'll always get a different result on every device you test on. Some will properly decode it. Some will just assume it's 2020, like a 2020 color matrix all the way through. Roku's in particular were really problematic because they'd start to decode it, realize they couldn't transmit this accurately over HDMI, and then just not transmit anything over HDMI. So you would just get flat output from the log, and it looked like we were getting a ton of media in this format. And it turns out that the reason why we were getting so much is FFmpeg, because FFmpeg has decoders for everything under the sun, including DNxHR. DNxHR is the successor to DNxHD, and DNxHD, as the name implies, is an HD codec. It was built with like 720 and 1080, and that's like all it did. It's a professional mezzanine format, which is another way of saying it's incredibly bad at compressing, because it's intra-only, it tries to be really accessible. But it turns out that this is one of that and ProRes are really the only two codecs that everything can export in that are royalty-free, and that you can, like, if you're downloading a free trial of any application or distributing it over the internet, a lot of the video production applications just didn't support anything but these two codecs for exporting in 10-bit, which is a shame because, you know, we've got this one at YouTube that we'd love everybody to use, and that's free, but it has seen limited adoption. The problem with DNxHD being from a broadcast world and only assuming HD is that HD implies 709 to broadcasters. So DNxHD didn't even have a field to specify the color space. It had no color information at all. And then as things started rolling around and DNxHR got released, which upgraded it for UHD, including the possibility of HDR and wide color gamut, they added a new field, and the new field was in a reserved bit, and the reserved bit says, please default me to 709 if nothing's written there. That way all the old files would actually work. But it gives you an opportunity to specify other color spaces, with the most notable one being deferred to container, and we'll talk about containers in a second. The problem is the default here is 0. You should never do that. Like if you have a default field that has a semantic meaning, then you have no way to tell whether or not someone meant to set that or whether or not. So FFmpeg was stomping on whenever it would pull in a DNxHR file, it would read the container would tell you exactly what it was, and it would open the DNxHR file, the DNxHR file would say nothing, and it would assume that nothing meant, please override this with 709. So you're spitting out media that all said it had a 709 matrix, so all the Rokus were joking. So, this is a point where I will actually praise the MPEG people, which is hard for me to do, but I'm doing it anyway. There's a coding independent code points doc that is the evolution of a bunch of independent standards that all did their own things with the idea of using numbers to represent color spaces, which seems like the easiest of problems, and yet it turns out things like this reserved nonsense show that, like, even just like picking which number to represent is really important. So here are the first 3 values from this table, and they did something really important. They assigned 0 is reserved, 1 is the default that you think it should be. They basically tell everybody, if it's 0, assume it's 1, but you actually have a way to tell the difference between those two things. You also have a way, if you are an application that has to do video processing, you can intentionally say, there's this other field that says, I don't know what happened. And that way you get like a cycle of intentionality, and you can find the point in your tool chain at which something breaks. So that having all of those options, then it goes on to list like 20 more, catching everything under the sun, which is nice. But I think the design of this default stuff is where that's one of those, like, people sat down, they thought about, like, forwards and backwards compatibility, and that's something that's been so far missing from the HDR space in a lot of ways, but this part got it right. So that's good. It's been incorporated into some standards. So for example, everything is symmetric within like H.264, H.265, and MP4 standards. They don't reference that other spec yet because that other spec is getting renamed because I don't know why. Everything's like coordinated. And for HDR production, almost everybody is using DaVinci Resolve. And this is, if you haven't used it, there's a free trial. I absolutely recommend go play around with it. It's grown into a full NLE, but it's got one of the most advanced color suites afterwards, which if you've never, 2 years ago, it's 3 years ago, when I started HDR, I had never done video color work. I didn't even know about post-production because I'm an engineer from the software side. So we don't know what video really is until you actually get into it for a few years. And so I absolutely recommend going to explore that if you've not had a chance to do any work with color. It's really eye-opening what you can actually pull off. But Resolve has a limited set of export options, and one of those things is MOV. MOV is the QuickTime file format, which is almost the same as BMFF, which is almost the same as MP4, but they're all separate standard documents, and they all are just slightly annoyingly different. So for instance, MOV has a way to specify all 3 of the color primaries, and MP4 has a way to specify all 3 of the color primaries. And they look the same, except they forgot an extra bit in MOV, so they added it into MP4, and now everything's named differently. Now the original name spec is controlled by Apple, and Apple actually updates it only when they're about to release a new version of Final Cut that includes whatever feature they're working on. All their software internally will be updated about 2 years before that, so that they can be sure about the backwards compatibility problem. So the iPhone actually understood what PQ color was 2 years in advance. It didn't do anything with that information, but it was in the library so they could probably identify it and log it. And then eventually they got around to releasing FCPX 10.4, and that supports HDR, which means it finally made it into spec. We worked with Blackmagic to actually get this in earlier than that because we really needed any way to do it, and we were counting on just where the code point would land and that everybody was using those common specs. So that's why I'm more rooting for that. But as we said in FFmpeg, when you would write this out, the only place to stick it was in the container level because DNxHR didn't have the way to express that yet, and the codec trumps the container, so we're misencoding all of that in FFmpeg. So that's the level. There are dozens of those bugs that we could go into, but I'm going to skip all the rest of them, just as an example of practical problems. Unfortunately, when HDR came out, not everybody did what this person did and threw away their SDR TVs. So when you make HDR content, we still mostly have to do tone mapping to produce an SDR version. And so we did some explorations here. All of these images are going to come from the Wikipedia article from High Dynamic Ranges, High Dynamic Range from user Kay McCoy. So these are 4, broad overview real quick. If you're not familiar, these are 4 images that show you high dynamic range photography. So these are this is a technique called multi-exposure bracketing. It comes from when cameras couldn't capture a proper high dynamic range exposure in a single shot because their sensors didn't have the dynamic range or noise thresholds to do it. Modern cameras are getting much better about this. Several of the latest cameras that came out this year can easily capture 15 stops, which is well above what traditional monitors can display and approaching the capability of the best HDR TVs. Cameras keep getting better. The red helium sensor is rated at something like 17 stops, which is amazing. So this is, once you get all that information, you can merge it together to produce an image that has that super wide dynamic range. And then you have to map it down to display on a conventional display. There are a few ways you could do that. One is you could just crush the contrast, which produces a nice, complete look, low in noise, very unsophisticated. What everybody ended up doing instead was this monstrosity, which is very
the future.
It's unrealistic. Hyper-realistic is the word that I usually use for it. It is the thing that you look at whenever you go to Redfin and look at the inside of somebody's house. Every photo is, I don't know why they turned every one of those up to the max, but the principle is you're enhancing local contrast by doing weird things to global contrast. So imagine that this is like a scan line of the image, you've got a dark region over here, and then it suddenly jumps to bright. What you do is you find an operator that screws with the global contrast in a way that allows you to boost the local contrast by suppressing image values in bright regions and raising them up in dark regions, but not doing so abruptly, because otherwise the image would lose its overall structure. So in this case, you make a ring around any high energy areas where you're going to multiply everything else up except the high energy areas. And so you end up with this, except then you get the weird ringing effect of like high energy areas are pushing into low energy areas. So that's already problematic. We just don't care for this as like on aesthetic purposes, but it has real big problems for video too. One of them is that the algorithm is unstable because it's looking at a frame by frame thing, so your haloing or ringing will be modulated as your image changes. So that it looks weird in a still frame, it looks even worse in video. You can see this if you look at a time lapse. Compiled time lapses often have this flicker problem. There are explicit filters that can get rid of it. There's a related problem in the audio field called pre-echo, which is anytime that you're taking energy and trying to smear it over a window in a way that, for compression purposes, which in this case it's not compression for space reduction, but it is compression of dynamic range, and they're taking energy and smearing it over time, and so you end up with energy that's displaced in time. And so we always have this, like, it's very artificial whenever we see that. There are ways to suppress it. One of the ways to do is to do like forward and backwards facing temporal things. So if you apply your tone mapping operator in 3D space, you can sort of suppress that to get a little bit more temporal constancy. It leads to weird artifacts. This is from a Pixar paper, where they showed that as you would have a scene-to-scene change of a high-motion object, that object would actually cut back in time. That door is not supposed to be transparent, but you can still see what's going to be in front of it before it happens. So this is pre-echo in the visual world. Dolby has fixed all of this with their very computationally expensive, very fiscally expensive Dolby Vision system. The problem that we have with that is simply that Dolby does not scale. For the YouTube audience, if a random YouTuber needs to call up Dolby and have a sales call before they can even think about exploring a piece of hardware, this doesn't work for us. So unfortunately, we're cut out from using what's probably the best system around right now, which is Dolby's. I give them credit for, they really nailed this problem. And instead, we do a simple static LUT profile, pretty simple. So if you haven't used a LUT before, short for lookup table, it maps any input color to an output color. It's completely static, no like contrast operations, no scene awareness. So this is pretty straightforward. One of the trick is you would obviously do a nice roll off in order to, so you've got a massive dynamic range. You want to do contrast suppression. So we clip the highlights a little bit. We do it smoothly so that there's no abrupt transition into clipped zone, because that's a really obvious thing. One trick is if you have, because we're going from a really bright, really wide space to a much narrower space, you have to deal with colors that are going to shift as they come in, because either they're just not representable in Rec 2020 and Rec 709 at any brightness, or more often they're Rec 709 colors, but they're super bright, which means that like red channel might be, if SDR white is 1.0, red channel might be 9.0, 2.0, 2.0, which is pretty deeply saturated red. But as it comes down, if you just clip everything naively, let's say that all shifts down to like 1.0, 1.5, 1.0, and then you normalize. So then now that's a much less saturated red. But it can also be if you have, if they're not symmetric in the coefficients, if it's a 9.0, 2.0, 0.0, then when they come down, that actually will change its angle in the chromaticity chart, in the like hue saturation value space. And so that is pretty visible. It can result in pretty severe distortions. So one of the tricks that we do is we actually make sure that whatever that hue angle is, that we preserve it, and then we bring down saturation and luminance together. Describing this was a good reminder that we should just open source this. It's not a lot of code to generate this. So I will look for that on a GitHub soon, because that's pretty useful. The problem with this is if the colorist, YouTube being a UGC site, we don't really get to have editorial control over what people upload. So the colorists can see that this will a lot of colorists, as soon as they get in front of a great HDR monitor, the first thing they'll do is just push everything up all the way and then be like, oh my god, this is cool. But the problem with that is it doesn't really work on consumer devices, especially doesn't work on when you try and map it down to SDR. You're trying to preserve an experience as best you can that just can't be represented in SDR. So you sort of need the ability to do custom grades for that, different between SDR and HDR. One nice thing to do would just actually have custom grades, but YouTube infrastructure can't support that. Actually, mostly for content security reasons, because people could upload an SDR version that is fine and that our content graders are all cool with, and then they upload an HDR version that in all of the highlights contains, for example, porn. And our content graders wouldn't be able to see that because they would have be looking at only the SDR master, because we have to upgrade our entire content review infrastructure to run on HDR capable displays, do SDR and HDR mastering at the same time. So we can't allow people, for safety reasons, to upload separate masters. So we have to use this LUT. And what we did about 2 days before launch, because all of our creators came back and were like, we don't like the look of this, it's too saturated on the SDR. So we created the ability to just shove a LUT on the side, which actually seems to work really well. It's not as sophisticated as people want. Sometimes people need to make a few compromises in their HDR grade in order to get their SDR master to come out well. But this has worked way better than we thought it would. We thought we'd have to be building a complete dynamic tone mapping system in like a month, and we've been putting that on the back burner to work on all of our other bugs. So the business stuff has a lot of implications. For example, we're doing Android's HDR implementation. If you have a lot of the most recent flagships, not the ones that are coming out this year, but anything already released, does HDR, and it does it entirely in software, which is pretty nuts. Qualcomm actually had the IP to integrate VP9 Profile 2 decoding in the chip that's in a lot of those devices, but they wouldn't do it because nobody was using it. And of course, nobody was using it because there were no processors that had VP9 Profile 2. So it's like, one thing that I will say that I am super excited about is Apple has now joined the Alliance for Open Media, which will give us, I think, good around-the-board signal that when we present a new format like AV1, that there will be broad instant adoption and that everybody should be on board so that we don't have this differential nonsense and end up doing 720p software decode that stops working after about 10 minutes of footage because your phone got too hot. When we released, the Pixel was broken by bad Android APIs, and then this is very interesting. The Pixel 2 does not have, it is not even sRGB, even if you set it to the calibrated mode. The Pixel 2 uses a D67 wide point because our product folks thought that it would be looking cooler, literally, a cooler color temperature, that it would look cooler metaphorically, and that the product would be differentiated by that. And as a result, everybody looks like a Cylon. It will get better. We are working on this throughout the Android ecosystem, at least. And I think that's true of, like, HDR is pushing a lot of tech companies to be like, all right, we need to pay attention to color. Again, I'm jealous of Apple because they've been doing this properly for a while, but we're catching up. Unfortunately, it's not just the tech companies, it's actually the classic TV manufacturers as well. So YouTube certifies TVs. We make sure that anything that has the YouTube logo in the living room space has a basic sanity test. And we started doing this because we realized that people were very bad at implementing a web browser. And so you would end up with really broken experiences, and people we'd rather have fewer better experiences because it's actually better for the users in the long run than a lot of really bad experiences. So we certify things, and we make sure that they have basic performance things, that they just that they work. That's all we're looking for. When it comes to HDR, we wanted to certify based on the absolute chromaticity. So this is to say, like, if you have Rec 709 color, really easy to represent, nothing crazy, but it's in the HDR color space, that it actually comes out the same color that that it went in as, that the processing, and it doesn't even have to be in the default mode. It's just like if you have a calibrated mode, make sure absolute chromaticity works. Relative luminance, we're not strictly concerned with the absolute brightness because displays vary, and for also other reasons that we'll get to later in the deck. So we made this little test chart, and each thing just has its relative luma and absolute chromaticity listed. Pretty straightforward. So we tried to measure all of these with a colorimeter and found absolute shit. No television that we could find came even close to having consistent colors or consistent relative gammas. And we were puzzled by this, so puzzled because we were trying to figure out, like, what's the acceptable range for certification? Like, if, you know, is 5% deviance or deviation acceptable? Is 10%? And it's like we were getting 20% across the board with everything. Eventually, we just dropped this from our certification program because, like, everything was coming back so incorrectly that we weren't actually certifying devices. And then we launched on Android, and we found something that we had never expected from Android, which was that almost all the flagship phones were coming with the OLED screens were coming out of the factory really well calibrated. The operating system was not doing any sort of color management, which is a failure that the Android team is addressing. But the displays themselves were actually pretty closely pegged all to D65 P3, which is, I think, what people wanted them to be in the display side of the thing, if we were taking advantage of it. So it turns out that the display folks were all doing factory calibration. It was working, and they all learned it from the TV folks, which means my earlier hypothesis that nobody, like, you can't make two TV sets look the same was entirely wrong. It turns out that literally every single device that we had tested was broken in some way about conveying the metadata from the decoder all the way across to the color engine. Every single device. I so frustrated when I learned this. It's limited to our own devices. The Chromecast didn't properly convey the signal for Rec 2020 color space when it was decoding VP9 content. LG and Samsung's flagship televisions just would ignore the metadata or do the wrong thing. They would pick it up and show the HDR logo as if they had understood, and then just use the wrong tone map. So once we realized that it was possible to go this, we just started going around and hammering everything. I think we've got everything hammered out so that if you actually watch a YouTube HDR video on a TV today, it should be correct. I have a pile of TVs in my bedroom that I just, like, every 2 weeks or so, I check for firmware updates, and then I check that the firmware updates didn't screw up HDR. So you need a team for this, unfortunately. It can be a one-person team, but, like, if you're doing something with HDR, you need somebody to just be on the ground with colorimeter, with a lot of experience, who is looking at stuff. Because it's so new, people are going to mess it up. So that was a hard lesson to do it. And if you're trying to work with third parties, you need to make sure that they understand what your expectations are. And that could mean transcoding in multiple formats. That could mean working with other device partners, or uploading something to YouTube and checking to make sure that it's consistent there between YouTube and your own application in different color formats, coming up with a standard test card. I'd love to see, like, a standard set of images that featured skin tones of diverse backgrounds that also were not uncomfortable in any way, which I don't think we have a good test set for in the industry. Speaking to Matt's earlier points about diversity and inclusiveness, we should build a library of, like, of that we could use for HDR specifically, and have use those as reference images across multiple platforms, and have, like, a Netflix test stream and a YouTube test stream and a whatever service test stream, so that you could always go, whatever your delivery platform, OTT or traditional broadcast or whatever it is, that you can actually see. So that's a thing. We recently took a delivery of a new Red original series. It is, that slide's out of place, sorry. It is I think one of our better series to date on an editorial basis, but it was also featured in HDR, and the HDR did not come through as expected, and so that was just some lessons to be learned there. The process for this is, it was all shot on location on a mountain, and then all the footage was sent to a finishing house for edit and color, and then that finishing house was sent to a separate media delivery house, and then the media delivery house handed off to an editorial team, and none of them knew how to watch it, because we hadn't, like, put HDR TVs or given them our own internal editorial team training on how to do these assets. So they were just uploading it, and the show went live without anybody having seen it in HDR. And then our creative director picked up his phone and said, "Oh, cool, I can watch this in HDR finally," and immediately got on the phone and was like, "What happened?" we can just run down the list of interesting problems here is the brand identity problems. So we have this logo. It looks fine on this TV because this TV is reasonably calibrated to 709. It turns out that our marketing folks decided to set our logo's color to be FFOOOO, which is fun. It's a fun color choice. I'm gonna drink a little FFOOO wine right now. It causes all sorts of problems, especially in HDR, because something that is that color is designed to be the reddest red that you see on a page. The brightest is supposed to pop. If you accurately cite that as an sRGB reference color within an HDR domain, it looks really dull compared to everything else. Even if you spin it up to be like diffuse white SDR, the red is not the most saturated red that you'll see. Even in a natural setting with skin tones, you will see colors that exceed the Rec 709 gamut. The intensity is not the highest that you'll see. It'll be much lower. So the effect of trying to be like the brightest thing, that's not, the brand identity just doesn't carry over well. Now if you do it literally and actually pass through FFOOO, it just breaks whatever you do in HDR, because now you have a 10,000 nit title card. That's just causes so much problems. So there's brand identity problems that need to be reconsidered. You need to like retool your assets and come up with, make sure that they're still carrying over their intended effect in HDR. We had problems with the initial delivery where they had forgotten to remove a tone map, and so the assets came through. They were in PQ. They were correctly marked as PQ, and they were like the values were in a place that would be consistent with PQ tone space, but they rolled off way too early. And so this is a problem with our. It's the idea behind broadcast safe again, where you have to put limits on the color volume, except it's the other way. That you actually have to say, no, the limits of this color volume in this media are too small. You must have done something wrong in your delivery process. In this case, they were mastering with the tone map on so that they could see the result within the color viewer on their desktop display before they hit export, and they forgot to remove it because, of course, Windows doesn't support HDR yet. Well, it sort of does, but it does it by creating a 10-bit Direct 3D or a fixed point 16 Direct 3D surface, and all of these apps are written in OpenGL so they can be cross-platform. So Premiere and Resolve and any of the main editing programs don't have any plans to support this because they have to completely rewrite their output layers. So that needs some work. The result of this is that you end up with weird solutions, like you have to have an external mastering monitor, and if you don't, it's pretty compromised. The other problem with this delivery is that the saturation was off the charts. It was so hot. And we went round after round of this as we thought it was a misconfiguration issue if somebody had Rec 709 output turned on, and then they're delivering it as if it was Rec 2020, which would result in everything being massively saturated. It sort of looked like that. Turns out that wasn't the issue. So here's a test. Tell me which one of these has skin tones that are more natural. And this experiment has only worked once out of 3 attempts, so we'll see it. But here's image 1. Here's image 2. And here's image 3. Okay, yes, it worked. Images 1 and 3 are identical.
I thought so. What?
Images 1 and 3 are identical. So what I did there is I inserted something that was so saturated, but within the space of 5 seconds, your eyes had already adapted to the saturation of this content, and this seems like a relief by comparison. An actual naturally colored image like is this, and when you see this for 5 seconds and I go back, now this one looks gross. So the problem was when they were loading all the footage into their edit system, they had an like old Resolve user colorist folklorist always use bypass for your input settings, which in an HDR world means use whatever your timeline color space is for your input settings. The timeline color space was PQ Rec 2020. So it was coming in as if it was that monstrosity all the way at the top of the deck where the footage is super blown out and really hot. So every time, for every scene, they would go in and immediately dial the footage back and it would look a lot better. And then they would turn off the grade to compare, because that's, the natural thing is like, check your input against your output, make sure you didn't do anything silly to somebody's face or something like that. And it would be way hot in the comparison thing. And so they'd be like, yeah, we dialed it back, it's great. And that recency effect was leading them to deliver a master that was just super saturated. And it wasn't a configuration issue. It was actually an edit process issue. So this is, I don't know what we need to do to fix this, aside from having, again, like standards on, go back to like an index of color safeness, not really about never exceeding it, but about like the main volume of your content should be within certain parameters, or have diagnostic tools about what's the 95th percentile of your saturation, what's the 50th percentile of your saturation throughout the content. So we're working on developing those standards as part of YouTube Originals guidelines. And we'd love to collaborate with everybody else if anybody has ideas on what they would be looking for in that space. One other problem was this footage had a lot of outdoors scenes in full daylight, and people have a tendency in SDR to stretch out the footage so that it uses 100% of the contrast range, because SDR is so limited, so much more limited than a natural scene. A natural scene might have a variation of 16 stops, even 20 stops if it's outdoors. SDR has a 6 to 8 stops depending on how you measure, so this is tiny. So one experiment is look around the room right now, find the darkest area in the room, and note how bright that darkest area is. There is no area in this room, to my eyes, that is completely black. Everything in this room has a little bit of value to it. But that's not what we do when we're producing an SDR master. So in an HDR world, true black is true black. If you're looking at it on an OLED display, which includes most of the devices that people are using, since mobile is more popular than TV right now in terms of distribution, very few of these colors are true black. In the cases where it's like one channel is true black, but the other ones are not at that particular value point. And that gives an image that has like room to breathe if it's an outdoor scene. It also gives you room to have contrast between indoor and outdoor scenes. You can still have highlights that peak all the way to 1,000 nits in indoor if you have an exposed bulb or something. But the rules about like stretch every scene out so that it would take up the full volume of space, they just led to this really monotonous, agonizing delivery of the program. It was just hard to sit through because every scene was just like bearing down on you, rather than having the outdoor scenes be kind of light and the indoor scenes be dark. And so again, that goes to like, we need content guidelines. Now the problem with this is that I was just an engineer in the chain, and we didn't really have anybody on the line who had HDR experience in the creative chain of command. And so that made the delivery process even more fun because I needed to figure out ways to handle that. So what I would recommend is if you are an engineer, you should do some photography. If you've never done photography before, do it, learn how to manage skin tones, learn how to manage light, because then you will be able to have a conversation like this adequately. Either that or like assign, or do the reverse if you're a creative person working on it, talk to your engineers and get some experience firsthand with HDR so that way you can be conversant in all the techniques, because this is it's the Wild West right now, and nobody knows what they're doing, and so we all need to figure it out together. If you have nothing else to do and you're a tech company, go find an indie director of photography and have them tell you what to do about your skin tones. One last section is on the delivery as we come back to metadata. There's a little bit of metadata in the PQ ecosystem where if you have a 2,000 nit TV and the program's peak is 1,000 nits, you might want to scale it up. That applies in reverse if you have a content that's coming in that's 2,000 nits and your TV can only display 1,000 nits. You might want to do some advanced tone mapping to roll that off smoothly. Basic rules. If you're transitioning from a dark scene to a light scene, you need room in your brightness range to add punch. And if you're going from a light scene to dark scene, the dark scene still needs to have enough detail that it won't be drowned out by the brightness. And so for that, you have two values that get plunked through: the content light level and the frame average luminance level. Content light level is the maximum brightness of the maximum average brightness of any scene, and the frame average. The other way around. Content light level is the peak value of any pixel. So it tells you what's the maximum you need to go. Frame average luminance level is the average, the maximum of any scene's average pixel values. So with those two, you can preserve those two rules of dark to light needs punch, light to dark needs detail. And nobody gets this right. It's like never correct, because you have to actually run through your program and reanalyze it before you put it into your output system. So that involves either a remuxing step or a full re-encoding pass, depending on how smart your encoder is, and nobody gets this right. Even if it's right, it could be wrong. So even if it's technically correct, then it might be conveying something other than the creative intent. So for instance, that YouTube Red Originals program, all of the titles, the text underneath people's interview segments or whatnot, were accidentally at 10,000 nits. They were sloppy, they missed this. But this, these things are blindingly bright. But what it told the televisions was, please crank this content all the way down because you're going to need room to display this at 10,000 nits. Now, it turns out this is enough of a problem, and has always been, that all the TVs just ignore this at this point. Every TV comes by default in HDR mode with dynamic contrast turned on, which is really unfortunate because the whole point of PQ was supposed to be that we had absolute mappings, but we screwed it up because we didn't get our metadata in order in time. And so now we don't have absolute mappings anymore, and the TVs just are constantly dynamically adapting their light volume when they're not in something like Dolby Vision where they know in advance. I will say that HLG does sidestep all of this by having a more sane set of default and maximum parameters. I'm a big fan of HLG for this reason. I think it's practical. I also think that we'll be cycling HDR technologies in 5 to 10 years, likely certainly in that OTT space where we have room to learn from all of the mistakes that we've just made with this tech rollout. So HLG being it's a good 5 to 10 year solution, and I think that's perfect. I think that's what we need right now. We don't need something to take us for the next 30 years, because we'll be re-ingesting, and nobody watches VHS anymore. Barely anybody watches a DVD anymore. So it's we can iterate on this. Now I would just beseech you, go watch something. Go actually shoot something if you can. If you have access to borrowlenses.com, you can get the new GH5S camera, which would be perfect for going out and doing a shoot for a day. So you can just get it, download a free copy, Resolve, give it a shot. If you've got access to a mastering monitor, there's some guides online that you can get started with. It's a ton of fun, and you will encounter as many problems as I did, if not more. This is my email address if you have any questions, or you can ask me any questions in person right now. And thank you very much for listening to all my problems.
Any questions?
Are you saying no TV is worth the money out there, right?
I have an LG C7 at home, and granted I did not pay for it because it's one of those certification TVs that I have to check, but I'm really satisfied with it, and if I had paid for it, I would not regret my purchase. Every TV out there is so much better than every TV that you would see 5 years ago. And from that perspective, they are great. I think the difference is we're entering a period again where, or I guess we've never had this, we're entering a period where your TV is a lot like your computer that you want to throw out the window after 4 years. And so it's changing people's cost perspectives and value perspectives on what a television is, which is going to be really interesting for that industry to adapt to. But the best TVs are worth the money today. You just have to know that they're not going to retain their value like they did.
Are there EQ tools that can help with some of these things? I can't quite tell which is your trained eye being able to see things wrong, and which we could, if we're doing things in a workflow.
FFmpeg has a filter that will just actually spit out some information. It needs some work before it makes sense for this, because you need to do it needs to run in 10-bit and then do a gamma, the actual proper decoding of the signal into a neutral space so that you can work across color formats. And then we could get some standard nit-based values for this stuff. So that filter's there, and I will go and fix it up. So that's, I think, the workflow that we'd recommend is ultimately is all open source tools. You just plug in this thing, you get a pile of CSV, just a CSV document, and then you pass it into whatever analysis that you need, and it spits that out. That is the approach that I think most people have been taking, aside from running a bespoke pipeline on a GPU that they've written themselves, which isn't that hard for these sort of statistics, but I'd rather see something out in the open tied-def because it can eat anything.
So I have a question about what's AV1 doing with HDR, and what's kind of the adaptability moving forward as things change in the space?
Yes, HDR. We have some HDR material in AV1's encoding set, so we are paying attention to. It is PQ only. We don't have HLG right now, but we're paying attention to how it performs with the more limited color volume, which can confuse things like chroma from luma. So all of the tools and compression figures that you're seeing in the overall are we compressed yet benchmark sets do include a limited amount of HDR material. AV1 also is being much more standard feeling than VP9 is. Instead of using a weird one-off codec color space flag, it uses the standard 2301-8 code points. Instead of not having any extensibility and making you stick everything on the container level, it has codec level extensibility like the SEI mechanism, so that you could do things like dynamic metadata right at the codec level. So it is picking up all the features that we think about and leaving room for any that we haven't quite thought of. So I think HDR performance will be right in line with HDR performance for whatever performance advantage you get from HEVC to AV1, you'll keep it for HDR.
So with these different standards, like HDR10+, these different standards out there, if we adopt to one, are we kind of in trouble if it doesn't fall through? Are they pretty much all backwards compatible, or how does that kind of work?
So both the dynamic metadata standards are optional, because if something breaks with them, as long as they don't like actively ruin your material due to bugs, but if something breaks with them, then everything, you haven't lost anything compared to any of the non-HDR deliveries. So depending on your engineering investment, it may or may not make sense. But popping HDR10 plus metadata into an HDR10 stream causes no damage to anything that can properly ignore SCI messages, which should be everything. It's a, we're actively looking into it, HDR10 plus in particular, but really any royalty-free dynamic metadata standard, because I do think that it would clean up some of the problems with like dynamic contrast and stuff like that. So,
Cool.
Tom, one more? Or can I see a hand? Cool.
Thank you.
Thank you.
Thank you. I forgot to do a little bio on him. Steve is with YouTube as a software engineer, and as I understand, he's skiing right after this, like right after, at night. So let's go. Yeah, let's go on a little break, and we'll have a kind of a lightning talk after.
Yeah, 5-minute break, and then,
Yep.
then we'll have Matt give us a little talk.
We're going to have.
Here for the day for this. Yeah. Oh, just for this? Yeah, so I work in the health. So, yeah, it's good to meet you. Good to meet you.